Hey, good morning, guys. Assalamu alaikum. Welcome back to Inspired Teens Grade 12 Mathematics. So in today's lesson, we'll be starting finance. Okay, fun. So, of course, we're going to be starting off with doing some grade 11 revision, okay, and doing some grade 11 questions with timelines. And then eventually we shall move on to what? We shall move on to grade 12 finance, okay, with future value and present value, okay. So the first thing we're going to start off discussing is simple interest. Okay, so simple interest you've been doing for many years, and we have these relatively simple formulas. Okay, so just some key words that that should immediately indicate to you that I should use simple interest are things like hire purchase as well as straight line depreciation. Okay, when you are given these concepts in a question, in like a 3-mark question, okay, someone buys something on hire purchase or straight line depreciation, this means simple interest. Okay, let's have a look at our simple interest formula. So we have A is equal to P, okay, 1 plus I times N or 1 minus I times N. So this is when we have depreciation, okay, and this is when we have appreciation, meaning when it grows, appreciation, okay, or inflation, okay, that's when we use a plus. Okay, when it's a minus, we use that for depreciation, when something is decreasing in value, and this here would be when something is increasing in value. Okay, so that's the plus and the minus. Let's discuss our other things. So we have N, okay, I guess we can write it out here. We have A, okay, A is the after amount, okay, or the accumulated amount. Okay, that's what you can think of. A, it is basically after interest. Okay, it's after interest has grown, or after the interest has depreciated something, or after the interest has increased something. Okay, that is what interest is, after interest or after the accumulated. Okay, P is the P, okay, is the principal amount. Okay, or you can think of it as previous amount, prior to interest. Okay, that's what P is. So P is before interest, A is after interest. Okay, then we have I, which is our interest rate. Okay, we put it as a value, interest rate, and we have N. In this case, it's simply number of years. Okay, for simple interest. Okay, and for compound interest, you'll see for the most part, this is number of years. So N we refer to as number of years. You'll see later on, we get more detailed about number of N, and we refer to it as number of payments. Okay, it's just that now for simple interest, you are making yearly payments. So the amount of payments would be the same as the amount of years. So that's why we regard as the number of years for now, and it would be this similar concept to when we discuss it later. But irrespective, number of payments is technically more accurate. Okay, so that's just the simple interest A, P, I, and N that's discussed. Some keywords we need to look out for, right? Let's have a look at compound interest, and let's discuss compound interest. So now compound interest can be separated into two. One is effective interest and the other is nominal interest. Okay, so effective interest is what we've been dealing with simple interest. Okay, we've been dealing with effective interest and as well as some part of compound. Okay, effective interest we've been dealing with in simple interest, and in effective interest is the most basic interest, where this is the key word. It is compounded yearly. Okay, we'll discuss about compounded monthly in a second, but compounded yearly basically means that we are going to make yearly payments. Okay, every year our interest compounds. Okay, and therefore every year we're going to make payments. Okay, so yearly payments. Okay, and some key words for this compound effective interest is reducing balance. Okay, so these the ones in red are minus, negative in the formula, and the ones in blue are positive in the formula. You'll see, we'll discuss the formula in a second. We have reducing balance / depreciation. So those are keywords that we know we need to use compound interest with a negative, and savings or inflation, we need to use compound interest with a positive. So here's the formulas, right? The difference between simple and compound is that the n, the number of years, or the number of payments, is in the power. Okay, so the rest is still the same. A is our after, P is our previous, I is our interest rate, N is number of years / number of payments. Okay, and that's when we have compounded yearly. There's of course our two different formulas. Okay, the minus for everything in red and the plus for everything in blue. Okay, now let us discuss nominal interest. Now, nominal interest is where it gets a bit more intricate, okay, and a bit more interesting. It's compounded less than a year. So your interest is compounded not yearly, not annually, less than a year. Now, let's see what we deal with, right? We deal with mainly 3 examples: compounded monthly, compounded quarterly, compounded semi-annually. So compounded monthly means that your interest is going to be compounded every single month, okay? And you are going to make monthly payments. That's the more important thing to us, right? Monthly payments. Oops. You are going to be making monthly payments. Now, compounded quarterly, that means that every 4 months you're going to make a payment. No, compounded quarterly, every 3 months you're going to make a payment. So, okay, I'm not going to write it out here. We'll discuss it when we do. There is a place later on in the notes where we will discuss it. Okay, so quarterly, please keep in mind, quarterly means every quarter of the year. Every quarter of the year is 3 months, because if you separate your year, which is 12, if you separate them into 4 quarters, you're going to get 3 months. Okay, so this is a bit tricky that every 3 months is a quarter and every 4 months is actually a third. Okay, so yes, just yeah. Okay, so just keep that in mind, very important, right? So nominal versus effective. Effective, we have it compounded yearly, but nominal, we have it compounded less than a year, and we have to take this into consideration. It introduces us to a new variable called M. Okay, it introduces us to a new variable called M, and this is how we allocate M in the formula. So previously, we just had A is equal to P, 1 minus I to the power of N, A is equal to P, 1 plus I to the power of N. Now, we have to actually, for each one, this could be plus or minus, mostly plus. Actually, whatever, it doesn't really matter, right? In this case now, as you can see, we have to divide our interest rate by how often it's compounded, okay? Because now each interval where we compound, that's where they're going to calculate interest rate on. Okay, each interval that compounds, so for example, you compound quarterly or compounding semi-annually, compounding monthly, whatever it is. Okay, each individual the time frame, that's where the interest rate is being compounded on, right? That's where they're calculating now how much interest you're owing them. So here they're calculating it basically like on a yearly basis. Okay, they owe us this much for the year, whatever it is. But here your interest is going to be calculated on different intervals like monthly, quarterly, less than a year, or semi-annually, right? And that's why we have to end up dividing our interest rate. Okay, so if the interest rate is going to compound monthly, you're going to divide that interest rate, because it's an annual yearly interest rate given. You're going to divide that interest rate by M to get that interest rate monthly. Okay, and what we're going to do here, this is important. Let me see. Okay, this is very important, very, 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 very important. Okay, why? Because, okay, this here represents number of years. This here represents M. How often is it compounded? Okay. When, okay, I'm just going to say the compounded. How I'm just going to put compounded. How often is it compounded? Okay. And, or just compound. Okay. And together, N times M, okay, gives us number of payments. And essentially, M gives us number of payments. How much number of payments a year is represented by M. Okay, so when we multiply the two, because remember I told you compounded, okay, so let's write it for this one. Compounded monthly means monthly payments. Now, we're no longer making payments on an annually basis. We are making payments monthly. So whenever we put this power as, it has to be number of payments. Okay, remember I said, even here, this is technically, and there is technically number of payments. It's just that because you make a payment every year, that's why you can put number of years. It doesn't matter. It's the same thing. That's for simple interest. So here also, this N is number of payments. And now in this case, how do we calculate number of payments? You take the number of years and you multiply it by compound. Compound means how many payments are you going to make a year? So if you're going to make 12 payments a year, you multiply it by however many years you're going to be making those payments, and it's going to give you the total amount of payments you're going to make in general. Okay, so that's what that means. Number of years, N times M. Okay, again, this N times M could be replaced by number of payments. It would mean the same thing. You take the number of years multiplied by how many payments you're going to make each month. It's going to give you the total amount of payments that you're going to make. Okay, and this, of course, this M is compound as well. Okay, A stays the same, P stays the same, everything stays the same. Okay, so excuse me. So that is what we refer to as the nominal interest rate. Okay, when it's compounded less than a year, that is our nominal interest rate. So effective, compounded yearly, nominal, compounded less than a year. Now we can convert between the two using this formula. Okay, this formula is not given in your formula sheet, so you need to memorize this formula. This formula is that 1 plus I effective, meaning the effective interest rate, right? The one that is compounded on a yearly basis, okay, plus 1 plus I nominal over M to the power of M. So this is a formula that helps us convert from nominal to effective or effective to nominal. There's questions, they could be sometimes, convert this effective to a nominal and vice versa. Alternatively, sometimes they'll give you the effective, and you are expected to understand that in the question, you need to use the nominal, okay, because it's compounded less than a year. So you'll need to convert from that effective interest rate to the nominal. Okay, so just keep that in mind. And like I said, this formula is not given, so you need to memorize this formula. 1 plus I effective is equal to 1 plus I nominal over M to the power of M. Okay, so that's our basics, basically, okay, of our compound interest as well as simple interest, right? Compound being separated into the two, effective and nominal, and what they mean, and the formulas that come from them respectively. Right, now before we do that, let's go ahead and start off a question. Okay, a simple compound interest / maybe there will be some simple interest formula questions, but let's go ahead and look at this question, right? So St. Mary's School buys a minibus at a cost of 920,000. Let me just get out my memo. Okay, St. Mary's School buys a minibus at a cost of 920,000 rand. The depreciation on the minibus is calculated at 21% per annum on a reducing balance basis. So look out for those keywords. All right, where are we? Compound interest, reducing balance is a keyword that tells us we are dealing with effective for compound interest. Okay, so let's go back to the question. It says the depreciation on a minibus is calculated at 21% per annum on a reducing balance basis. Calculate the value of the minibus depreciation at the value of the minibus after depreciation at the end of 6 years. So for A, we are simply going to calculate the depreciation. Okay, so that we know that it costs 920,000 rand. It's going to depreciate at 21% per annum on a reducing balance basis. They want us to calculate it at the end of 6 years. So this is our regular compound interest formula, 1 minus I, because it's depreciation, to the power of N. Okay, compound interest because reducing balance. Now, A is what it's going to be after those 6 years. Okay, after those 6 years. P is our principal amount, 920,000. 1 minus, what is our interest rate? Our interest rate is 21%. Now you can either put 21% and then please make sure you put the percentage sign in your calculator. Alternatively, I would just convert it to a decimal, really simple, divide by 100, you get 0.21. Okay, so minus 0.21, okay, to the power of 6, because it's 6 years. Remember, we're still dealing with effective interest. Effective interest essentially this is compounded yearly, meaning there's yearly payments. So the number of payments is going to be the same as the number of the years. So this, after we do this calculation, right, after 6 years, this 920,000 on a depreciation rate of 21% is going to depreciate to a value, a sad value of 223,640,46. If you're doing these calculations along with me, please let me know if I do any incorrect values, if I give you any incorrect values. Okay, so this minibus actually depreciates to that value after 6 years. So these are, by the way, I'm pretty sure these are like 3 easy questions that we're starting off with. Okay, just to sort of wet our taste buds. Okay, so let's look at the next one, B. What would the straight line depreciation rate that would yield the same amount in 6 years' time? Let's read that again. What would the straight line depreciation rate be that would yield the same amount in 6 years' time? So straight line depreciation, by the way, if we go back, right? Straight line depreciation, we said, what is this? Simple interest. So they're asking, oh, if this was actually calculated with simple interest, what would the percentage be to accumulate to the same value, to not accumulate, to depreciate to the same value? Okay, so it's a bit of a tricky question, like the wording or the understanding. Okay, but the calculation is pretty simple. We're substituting into the formula. So for B, we're going to use A is equal to, now we're going to have to use simple interest because straight line depreciation, P open brackets 1 minus, it's still depreciation, right? 1 minus I times N. Okay, now what do we do? So you see, they say, what would the straight line depreciation rate be? So what are we calculating? We are calculating the depreciation rate, the straight line depreciation rate, which is the percent, right? The rate, the interest rate. Okay, or the depreciation rate, interest rate, is a similar concept. We're talking about the percentage rate at which this amount is growing or decreasing. Okay, so we actually want to calculate I. That's the thing. We want to get I. So if we want to calculate I, we need to know A, we need to know P, we need to know N. Okay, and of all we actually do know, right? So what is A? A is after it depreciates. So in this case, they told us they want us to calculate the percentage that it would what is the division that would yield, that the percentage where this amount 920,000 would actually depreciate to the same value that it depreciated with the compound interest. That's what they want us to calculate. So afterwards they want the amount to be the same as what it depreciated for the compound interest. So 223,640,46. That's our after. After depreciation, they want it to be equal to that amount, and we're going to calculate the I. The principal value is still the same, 920,000. 1 minus I is what we want to calculate, and it's the same time frame, so 6 years. Okay, all of this is still the same. Okay, all of this is still the same. Okay, so I hope this makes sense, right? The after amount is what we actually know, and I is what we want to calculate. Okay, so now we can take this over as division. So it becomes 223,640,46 divided by 920. Okay, so then on this side we'd be left with 1 minus 6I. Okay, so in this case, what I can do is you can either simplify this value. You can do one of two things. Okay, simplify this value or write it with that value, whichever one you end up preferring. Please, once you do practice, you'll be able to judge and see, okay, I actually prefer this. I make less mistakes when I do this. Like I actually just prefer writing everything out as is, and then like doing it as in its most like least simplified form, and then putting it into the calculator to get a more accurate answer. Because oftentimes you see, like if I simplify this fraction, I'm going to get a really weird number, 223,640.46 divided by 920,000. Okay, I'm going to get a really long decimal, and in finance we cannot round off initially. we cannot round off initially because we are going to get inaccurate answers. So that's the thing, right? In finance, by the way, this is another thing, is to not round off in the middle of your steps because it's going to lead to inaccurate answers. So here, when I simplify this guy, it becomes 0, 0,2430 8745 8745 65. So I have to write out the entire thing. Alternatively, you could leave it as a fraction. Now I simplify this side. I want to leave I alone. So I can take -1 over it, becomes -1. And then I can also divide it by 6. And I'll get I. Okay, I'm just going to show how I done that. I'm just going to call this X. So X minus 1 is equal to -6I. And I divided both sides by -6. And that's how I got X, which is that, -1 over -6. Okay, so now that's how I basically calculate I. And now this I can directly put into my calculator. So I can use the answer feature. I'm going to say answer -1 divided by -6. And I get an interest rate. And you're going to initially get it as decimals. And you're going to have to multiply it by 100 to convert it to a percentage. You're going to get 0,12615. And this simplifies to the interest rate being, multiply this by 100, round to 2 decimal places. Your final answer is the only thing you should round. 12,62%. Okay, only round off your final answer to 2 decimal places. If you're going to simplify this, do not round it off. Okay, let's see what answer we get when we round it off. 0,2431 divided by -6 -1. Okay, actually this one is pretty similar, but in some cases you're going to get an inaccurate answer. So don't round off. Okay, it's really not ideal to round off. In this specific case, maybe it's a more simple example. We'll get the same answer, but in the more complicated examples, trust me, you're not going to get the same answer. Okay, so that's how we do that question B. Let's go ahead and do C. Okay, so just recap one more time for B. What would the straight line depreciation rate be? That would yield the same amount. Yield means like depreciate to, or the after amount, yield. Okay, how much was produced if you do like chemistry, but like yield is how much would be at the end, essentially. Okay, so that's why we knew the A, we knew the B, they wanted us to calculate the I. Okay, let's look at C. Calculate the estimated cost of a new minibus in 6 years' time if the expected rate of inflation is compound interest, so they're positive. Let's just get rid of this to not confuse that. Inflation. Inflation. Oops. Okay, inflation is compound interest with a plus sign, positive because it increases. Okay, so now we are going to use the formula. A is equal to P, open brackets 1 plus I to the power of N, plus being the key. Okay, so now they want us to calculate the estimated cost of a new minibus 6 years from now. Okay, 6 years from now, it's how much is it going to be in the future after inflation. So we're calculating A. P is the principal amount, okay, because remember the minibus currently costs what? 920,000, and now it's going to inflate. We need to calculate that. So 920. 1 plus, what's our interest rate? 6.3. So that's actually 0,063. Okay. In what? In 6 years' time. So we are calculating how much is this 920,000 going to grow with an inflation rate of 6.3% in 6 years' time. That's what we're essentially calculating. And what the answer is, it grows to 920,000 with inflation taken into consideration, it grows to 1,327,355.99 cents. Okay, always use your 2 decimal places, round off to 2 decimal places. Okay, so there we go, right? Depreciation on a reducing balance method, calculating the interest of how much a certain amount would depreciate to a certain amount, and an inflation, a simple inflation rate question. So just practicing these compound interest formulas. I hope that these are making sense so far. Okay, let's have a look at this one. Mary takes out a loan of 530,000 to start her own business. The interest charged on the loan is 8% per annum, compounded semi-annually. Cool. So we're dealing with our normal interest for the first time, yeah? Okay, the interest charge on the loan is 8% per annum, compounded. What tells us is nominal? Keyword compounded. Okay, compounded semi-annually for the first year, and then is increased to 8.5% per annum, compounded monthly at the end of 6 months. At the end of 6 months. Oh, sorry, that's a full stop. At the end of 6 months, she repays 120,000. 12 months later, she repays another 270,000. She makes a final payment 2 years after she started her business. Determines the amount of her final payment with which she amortizes the loan. Amortizes basically means pays off completely. Okay, so it sounds a bit complicated, right? So what we're going to do is we're going to take it like step by step. So we need to understand. So these with these type of questions, right? When you see that someone takes out a loan or they're paying back or whatever it is, okay, and like initially for the first 2 years the interest rate was 2, and then the interest rate became 5, and then at the end of 6 months she made a payment. At the end of 8 years she made a deposit. Okay, when we have these withdrawals, deposits, and change of interest rates, this is now when we create a timeline. Okay, because we have to create a timeline. We have to create a timeline because we need to be able to show, okay, all the different changes with respect to time, because time is very important, right? Because the longer you leave something, the higher it grows in interest rate. The shorter you leave something, the lower its interest rate is. So in order to calculate an accurate amount of interest and the accurate amount that she owes, we need to have the right time, right? How much did the interest rate grow before she actually made her first payment? Okay, how much did the interest rate grow before she made her first withdrawal? And then after that withdrawal, the interest rate changed. How long did it change for? Okay, it changed for 2 years. So now we need to change that interest rate and calculate it according to 2 years and all of those details, right? So that's why we have to create a timeline and put all of our events on a timeline. Okay, so we start off our timeline here. And let's end it here. Excuse me. Okay, so we call this T0, and then this will be the end. Start and end. Okay, so T0 is the start. The end, we still need to determine like what's the final last time frame that the loan was paid off, and they tell us, but we'll fill it in as we go. So Mary takes out a loan of 530 to start out her own business. So that's T0. When the loan is taken out, that's T0. That's the start of all of this calculations, is when the loan is taken out. So let's just use think it's fine. 530,000 rand was taken out as a loan at the initial time T0. We'll refer to it as T0. Okay, the interest rate charged on the loan is 8% per annum, compounded semi-annually for the first year, and is then increased to 8.5% per annum, compounded monthly. Okay, we'll come back to that, right? But for now, here we have things with regards to interest rate. So the interest rate on the loan is 8% per annum, compounded semi-annually for the first year, right? It is then, let's use this, it is then increased to 8.5% per annum, compounded monthly. Okay, so that's for the interest rate. Now, at the end of 6 months, she repays 120,000 rand, and 12 months later, she repays another 270 payments. So we call this like balloon payments. Okay, she's making large sums of money. So in this case, she actually wasn't making monthly payments towards her loan, but she was maybe accumulating money, right? She obviously was earning money in her business. So she was making these large sums of money, like 120,000, 270,000. She was making these payments, right? And she made her final, okay, so just before we move on, these are payments. She repays, so at the end of 6 months, she repays 120,000, and then 12 months later, okay, she repays another 270,000. So those are payments. So the first two are interest rate changes, and then these are payments. Okay, So then they say she makes her final payment 2 years after she started her business. Determine the amount of her final payment, which amortizes the loan. So now we've established what is the end date. The end date is 2 years later. So we call this T2. So we use years. Okay, we use years. So the end date when she amortizes, when she makes the final payment for the loan, is 2 years after it was taken. Okay, so the end is 2 years. Now we are going to slot each change onto our little timeline. So let's use pink to annotate our interest changes. So the interest on the loan is 8% per annum, compounded semi-annually for the first year. So what I need to do is I need to make a little thing at 1 year. At t is equal to 1, there's a change. Okay, we refer to this as the change. This is how I'm going to refer to it as, and this is how I want you to understand. At T1, meaning at the end of the first year, there was a change. It's either going to be a withdrawal, deposit, whatever it is, or an interest rate change, which is what this one is. So at T1, the reason I put an interval, I only put intervals on this timeline for changes, any sort of change that happens. So the reason I put T1 is because there's going to be a change that happens. So before this is what we're going to have. The interest rate, this is how I like to represent it, from T0 to T1, okay, we had a specific interest rate. Okay, we had a specific interest rate from T0 to T1. Okay, so let's just use this in black. Initially, she took out a loan of 530,000. Okay, so for the first year, okay, so for the first year, we have a specific interest rate, and I'm going to write it on my timeline so it's easier to see. So for the first year, there is the interest rate, so you can write I is equal to 8%. Okay, I is equal to 8%. And what else do we have? Compounded semi-annually, so actually M is 2. Okay, remember number of payments, if we go back here quickly, right, here we have it here. Compounded monthly, M is 12 because we make 12 payments, because we make a payment every month. Compounded quarterly, okay, we make 4 payments because we make a payment basically every 3 months. Compounded semi-annually, we make 2 payments because we basically make a payment every 6 months. Okay, so that's why in this case, that's what we need to make note of, I as well as M, right? The two important things. Okay, cool. So that's the interest rate change. That's the first one done, essentially 8% per annum, compounded semi-annually for the first year. We showed that on our timeline. Let's do the next one, increased by 8.5% compounded monthly. Okay, then it increased to 8.5% compounded monthly because they don't specify for how long. It's safe to assume that it was till the end of the loan, till the end of the loan, basically, till the rest of the time. It was the new interest rate, essentially. Okay, so let's allocate for that. Okay, what did the interest rate change to? It is changed to 8.5% compounded monthly. So the I is now 8.5% compounded monthly. M is now 12. Okay, so 2 changes were made to the interest rate, and we're representing this nicely on our timeline. Initially, I is 8%, M is 2, this is 8.5%, M is 12. So now we have represented the change at T1 of the interest rates. Now, so that's done. Now what we need to do next is, at the end of 6 months, she repays 120,000 rand. So a payment, she's making a payment into her account, right? So payments is basically decreasing the loan, because now she's making a payment towards the loan. It's decreasing amount she owes. So with regards to payments, after 6 months, at the end of 6 months, so 6 months is between 0 and 1 year, okay, and 6 months is half of a year, so I'm going to put 0.5. What happens is she makes a payment, so I'm going to put minus, because we're talking about the amount she owes, the loan amount, minus 120,000 rand, because at the end of 6 months she makes a payment of 120,000 rand. So she subtracts from what she owes the bank. So that's done. At the end of 6 months, she repays 120,000 represented. 12 months later, so at the end of 6 months, she makes the payment, and then 12 months later, meaning 12 months after the first 6 months. 12 months after 6 months is going to be 1.5 years. At 1.5 years, we can say T1,5. What happens? She repays another 270,000. So from the amount she owes them, 270,000 she pays, so minus 270,000 from the loan amount. Okay, she made a final payment 2 years after she started. We put that in the timeline as well. Determine the amount of a final payment which she amortizes the loan. So this timeline is golden in answering this question. You don't even now need the question because everything can be seen from the timeline. Oh, okay. This person takes out a loan of 530,000. The interest rate for the first how long? 1 year is 8% compounded semi-annually. Okay, in that first year, 6 months in, they made a payment of 120,000 towards that loan. Right. Then for the second year, what happens is the interest rate became 8.5% per annum, compounded monthly. Okay, and then at 1.5 year point, right, at the 18-month point, they made a payment of 270,000. Perfect. And then they made their final payment because this timeline ends at T2. They made their final payment 2 years after it was initially taken. Okay, so now that we made these changes, right, there needs to be like intervals. So what we need to do is we can calculate. This is how you do it all the time. You calculate how much the loan grows between each change. So from 0, we have uninterruption. We start off at 0. Okay, we take out the loan of 530,000. The loan is growing until the first change. We think of a change as a little bit of a disruption. So let's calculate how much the loan grew for the first 6 months before she made that payment. So again, we're going to use basic compound interest. A is equal to P, open brackets 1 plus I to the power of N. And actually now, because it is nominal interest, you don't have to write this, but it's I and N times M. Okay, so the principal amount is 530,000. Okay. 1 plus I, interest rate initially is 8%, so 0.08, 8%. Okay. Divided by how often is it compounded? It's compounded semi-annually, so divided by 2 to the power of N times M. How many years? Okay, how many years did it grow for before this change? It only grew for half a year, so 0.5 multiplied by M, which is 2. Okay, so that's how we represent that. And why did we stop there? So let's just get this answer first. This answer is 551,200. Okay, so for the first 6 months, what happened is this 530,000 that she was owing because of the interest rate grew to 551,200. So now she no longer owes 530,000. After 6 months, she actually owes 551,200 because interest grows over time. Now, the reason we stopped at the 6 month period, and you're going to see, we're going to go from 6 months to the next change. The next line is at T1. Then we're going to go to the next change. The next change is at T1,5. Then we're going to go to the next change, and the next change is at 2 years, right? That's how we're going to take it, interval by interval. That's why we allocated these onto the time interval also, so we know where to stop. Okay, because these are disruptions, these are payments, these are interest rates being changed. Okay, these are changes that are happening. Okay, so what we then do is once we calculate how much we follow this timeline, we follow the chain of events that happens. So we calculate how much it grows for the first 6 months. Why first 6 months? Because it's the 6th month. At the 6th month, there's a change. Okay, what change was made? So T0, 1, by the way, there's 1 month, 2 months, 3 months, 4 months, 5 months passed, and now we got to the 6th month, and it grew to 551,000. So now she owes them 551,000, but she makes a payment. She makes a payment of 120,000. So we subtract it. Okay, we subtract it from the amount that she owes after 6 months, and we get the amount of 431,200. So because now at the end of 6 months, because she made the payment, she no longer owes them 551, she now owes them 200. Okay, and we continue. So from the 0.5 mark, we continue to T1. So now, with that amount that we just calculated that she owes after 6 months, she owes whatever amount we got, we then need to grow that amount for the next period until there's another change. So it grows for basically 6 months until there's going to be actually an interest change. Okay, so how much does she owe them now? She now owes them 431,200. And this amount is going to grow for the next 6 months until the next change is made. 1 plus I. Now we can see on this timeline that for the next 6 months, the interest rate is the same. Sorry, yeah, I don't know if I said earlier this change was an interest rate. No, it wasn't an interest rate change. It was a payment. Now the next change is an interest rate change. So we have to stop there. We stop at every change. So this thing goes for 6 months. The interest rate currently is still 8%. It's still compounded semi-annually. Okay. And we're going to stop at half a year because that's when the next change is. So it's N times M. When we do this calculation, we get an amount of 448,448. $448,448. So essentially, like if you want to keep track of how much she owes at each interval, at T 0,5, she now owes, after she makes that payment, 431,200. Okay, at T1, she now owes 448,448. Now, why did we stop at T1? Because we can't carry on till the next payment because there was an interest change. So things have to change in the calculation. So that's now we take this amount that she owes after 1 year and we grow it till the next change. Where is the next change? The next change can be found at T1.5. So we grow it for another 6 months. Okay, it's not always fixed intervals. You'll see they differ. Okay, we grow it for another 6 months, but now we have to make that interest change. So 448, 1 plus, the interest rate has now changed. It's not no longer 8%, it's now 8.5, and it's compounded monthly. But we still go for 6 months. We don't go till the end of the year because we want to stop at that change. Okay, this is where the change was made. So we're going to stop at where the next change was made, make that change, and then continue growing it. So we grow it until a change was made. We make that change at that point and continue growing it until the next change is made. So this is going to be 0.085 divided by 12 this time. And again, how long are we calculating it for? Again, 6 months. But now multiplied by 12 in this case because 0.5 times 12, but it's compounded monthly. Okay, this gives us an answer of 467,847,75. Now, this is after the 1.5 year period. So why did we stop at this 1.5 mark? Because a payment was made. That was a change. Okay, so we need to make this payment minus, how much did she pay? 270,000. 270,000. Okay, so we make this payment. Once she makes this payment, she no longer owes them that big amount of 467,000. She now owes them the difference, which is 197,847,75. Okay, that's what she now owes them. So after she makes this payment, we can take note if we like, 197,447,75. That's what she owes them now. Okay. Then remember, she makes a final payment when? She makes her final payment at the end of 2 years. So from that 1.5 year mark to the 2 year mark, the money she still owes. So that's a 6 month period where the money is going to grow. The amount of interest is going to grow, and the amount that she owes is going to constantly increase. So from now till the end, okay, so from this point, she owes 197,847,75 plus the interest rate is still the new one, 0.085 compounded monthly, okay, to the power of half a year multiplied by its compounded monthly, so 12. Okay, so it grows in the account until she's ready to make the first payment. So we grow it for another 6 months. Okay, and when we do this calculation, this loan amount grows to 206,406.59. Okay, so essentially, right, after this 2 year period, she making a payment of negative 120, then the interest rate changed, then she made another payment of negative 270, then finally, and then grew for another 6 months. She now, at the end of 2 years, owes them 206,406.59. So of course, if she owes them that after 2 years and they say that she amortizes the loan, meaning she ends the loan, she has to pay all of that. So the amount she owes at the end is this amount. What is her final payment? Because they do tell us she does finish paying off the loan. Okay, so since she paid off the loan, that obviously means she paid for everything. So since she did pay for everything, this is the amount that she owed. So she had to pay that entire amount in order to amortize the loan. So therefore, that is her final payment, 206,406.59. Sure, it was a lot. Okay, but yeah, I hope that you understand the concept of the timeline. Okay, maybe it's many of you, what you do is you calculate, not many of you, but there might be another way to calculate the entire thing, right? And then subtract these and how much they grow. For me personally, this is a longer method for sure. It is a bit longer. As you can see, there's a few more steps, okay, then maybe that you can have. But okay, this is a method that makes sense, okay, to follow the timeline, to understand that you just need to allocate your interest changes, your payments, your withdrawals, and you calculate how much it grows till the next change, how much it grows till the next change, how much it grows till the next change, literally, how much it grows till the next change, make that change, how much will it grow till the next change, make that change, how much will it grow till the next change, make that change, and so on. Okay, you just keep doing that, and you'll see like, yeah, like sometimes like obviously these are like set 6-month intervals, okay, but it's not always going to be like that. Okay, either way, we're going to end there. I see someone has their hand raised, so if you would like to ask a question, I allowed you to speak, so you can ask your question. Do you round off along the way for time? No, you don't. Oh, did I in this case? Yes. I'm pretty sure I did. Let me just 448 1 plus. Yes, okay. Thank you for that question. Actually, yes, you can round off. Okay, I think you can round off. Okay, when it comes to a timeline question in between. Okay, you see the thing where not rounding off comes into play. Okay, is when you have these like complicated fractions. Okay, and like you're rearranging the formula, and you're changing the subject of the formula. That's a good question, by the way. Thank you. Okay, when it comes to these fractions and doing these complicated things, taking the 1 over, okay, and actually more so, maybe these are more simple examples like compound interest, simple interest. When it comes to grade 12, when we do future value and present value, this is this you definitely cannot be rounding off, okay, because here the answers would differ a lot. Okay, but either way, when it comes to like these, I wouldn't suggest rounding off just to get the more accurate answer. Like you don't want to be rounding off here and then not rounding off there. Okay, however, I'll tell you when you can round off is if you're using this entire formula. In a timeline question, for sure, you can round off. Okay, because these are like cents and the cents are not going to make a huge difference. Okay, like for example, here you'll get 0.69 or whatever. Either way, this is a rand amount and you need to round it off in order to get it to the next amount. Like if we consider it in the bank, for example, like if they tell us she owes 197,847.75, they're not going to add that 69 in, they'll just round it up type thing, but obviously we just round it off. So yes, in a timeline question, to answer your question, in a timeline question, you can round off. Okay, when you're basically doing this, you're calculating the rand amount that it accumulates to after a certain time frame. You can round off. Okay, but yeah, okay, look, so let's end it there. Next week, what we'll do is I'll still decide. We'll probably maybe doing like 2 more questions and then start grade 12 work, or let's see how it goes. I'll have a look at the next few questions and see if there's anything really important that we need to touch on, or if you guys can practice them on your own and I can give you guys the memo. Okay. But yeah, again, let me just go through this one more time. Timeline question. Okay, we need to indicate our start period, our end period, and all the different changes that were made in between. Okay, and you put them in chronological order. That is interest changes and payments. Okay, you'll see maybe if you do another example, or if we end up doing another example, sometimes there's withdrawals that are made. there's payments that are made. Okay, so sometimes we can add to the amount we owe, sometimes we can decrease from the amount we owe, all of that. And when we deal with investments, it works slightly different. Okay, but nevertheless, it follows the same logic. Okay, cool. But yeah, let's end it there. And then I hope that you guys understood what we did today. Please, if you have any questions, I'm going to leave the meeting open for the next few minutes, at least 5 to 10 minutes, depending if people have any questions. Please do ask any questions. And again, remember, you can unmute your mic if you'd like to ask the question like verbally and not in chat. But yeah. Cool, that's it. I do encourage you to ask questions if you do have any questions. Okay, but for those of you who do need to leave, you are free to leave. The class has ended. Okay, it doesn't appear that anyone has any more questions, so let us end it there. Thank you guys again so much for joining. I will see you guys next week. Please do have a good rest of your week at school, and thank you again. Jazakallah khair.